Hello, I'm Isaac Cunin, Senior Product Manager at Snowflake, and I'm here to talk to you today about Snowflake extensibility and some of the exciting work that we're doing in the space, some of which is out and some of which isn't. So we're going to recap today some of the stuff that is already in public preview, yeah, give you a few demos of some of the stuff that's there and some of the stuff you can actually go and play with, get your hands on right now. We're also going to take a peek at some of the exciting things that are really coming. And so I really like to view this as a roadmap. It's a long roadmap of features that we're going to be bringing out, not a one and done by any stretch. And so I want to show you some of the cool things that we have in store that isn't there yet, but will be coming. So with that, let's get started and actually look at some of the fun stuff that we have. So starting with that bit of a feature recap. So I like to start with a bit of a mental map when I talk about these features. We're talking about extensibility in Snowflake, and there are some different classes of things that we work on or that we work with. So one class of things that we talk about are things like JavaScript functions, external functions, Java functions, which are really JVM functions. We're running a JVM inside the engine. We'll talk about more about that. You can run code that's written in Java, but also languages like Scala that run in the JVM. What's cool about these features is that they really plug right into Snowflake's engine, right into Snowflake's query processor, and make Snowflake do things that it couldn't do before, right? So if you've got some fancy logic, some business logic, some computational, whatever drives your business that you wish Snowflake could do, these give you that opportunity to really push that knowledge, that know-how right into Snowflake's engine. So JavaScript functions, of course, have been with us for quite a long time. They actually predate me at Snowflake. External functions was one of the first features that I worked on here and is now actually GA. So you can go and you can bind logic to a REST endpoint that you have somewhere out on the internet and bring that logic right into your Snowflake queries. And then these Java functions are really that new piece that we're bringing. Now, the other big item that we've been talking about a lot recently is the Snowpark API. And so the Snowpark API really works on top of Snowflake's engine. You can think of it today as being sort of at the same tier as JDBC, right? So you're going to write a client program that uses Snowpark's API to do things in Snowflake much easier. So instead of writing strings that go into, or SQL that goes into strings and passing those around, you actually get these deep language integrated interactions with data and the ability to push computation right into Snowflake. And so Snowpark can really use any functionality that's in Snowflake, including functionality that you've written with any of these languages at the bottom. But there's kind of this privileged model today with the current Snowpark for Scala and the JVM. And we're going to talk about how that works to really make some neat features light up rather in the Snowpark API. So yes, today we're not going to focus on all of this. We're going to focus really on that Snowpark API and the JVM, and then some of the cool new things that are coming with regard to those too. So before we jump in and really, I want to do some demos and show you some code today, but just sort of to ground ourselves, let's look at a few scenarios that you might want to accomplish with these features. So one of them, ML is super hot. Everybody wants to apply ML models to their data. And of course, if you've got your data in Snowflake, you'd really like to be able to do that scoring of data right inside the engine, right? So maybe you have emails coming in and you want to apply some sentiment model. We'll actually do a little bit of a sentiment analysis here in a very rudimentary way, but you might want to do that with ML and do that in a pipeline that you have right inside of Snowflake. And so you can do that now with our Java function. If you put Java and Snowpark together, you can do cool things where you use Java, for example, to express what PII might look like. And I've done a bunch of demos on that in previous sessions. So you have a PII detecting function or a masking function maybe, and then you can use Snowpark to very easily iterate over your data, right? So Snowpark can generate queries that are schema sensitive. So you can, for example, with Snowpark, inspect your table, find all the string columns, and then apply your PII routine to all of those and do it in a very repeatable way. Another common thing that we see customers doing is that they have logic that they use elsewhere in their business. It might be things like detecting or correcting their own product codes. Maybe they have a particular format. Maybe they've got some sort of credit scoring algorithm that they use elsewhere. And they want to bring that logic and use it inside Snowflake. And of course, Java is a pretty commonly used language. This gives you the opportunity to really take that same code, pick it up, and move it into the database and not have to rewrite stuff to get it working inside Snowflake. And then finally, a big driver of Snowpark usage is simply that you've got developers that want to work with data, but maybe aren't SQL experts, or maybe they're experts in another language already and want to be able to leverage those skills, get the benefits of writing code that's deeply embedded in those languages. And so you can work directly against Snowflake using those languages. And again, starting with Scala, but we'll be bringing others online as time goes on. So those are some high-level scenarios. Let's jump in and talk a little bit more about each of these features. So remember, Java UDFs is really about bringing code into Snowflake and running it right in that warehouse that you already have. There are now two ways to go and build these. So the first way that we had is illustrated here is you could go and build a Java function using your own tooling. You know, my favorite tool, my tool of choice is VS Code, but you know, you can use things like IntelliJ or Eclipse to go build your Java function outside. You'd go and you'd build that code, you'd jar it up, and you drop it on a Snowflake stage. So you upload it to Snowflake really just like any other file. And then inside Snowflake, you can go and bind that function to a SQL function, right? Write a SQL function that understands under the covers that it's really going to be calling into Java. And then you can go ahead and use that in all of your queries. We'll see an example of how this works. Now, this method is super powerful, especially for complex code, right? So if you have complicated code that, you know, maybe it's large, right? Maybe you're reusing code from somewhere else. You want the kinds of tools that those external development environments give you, things like IntelliSense and debugging, the ability to check your code into source control and work with other people, things like profiling tools, right? We don't have those in Snowflake, at least we don't have them in Snowflake yet, but all these tools do exist out there and you want to be able to leverage those. But it's sort of overkill for simple cases, right? If I just have some little bit of code, I have to go through all of these steps where I use an external tool to write it, compile it, I have to jar it up, I have to put it on a stage and then bind it so I can use it. And so we've also created sort of a lightweight path, which we call inline. And so with an inline definition, I can write some very simple SQL code that actually goes and embeds the Java code right inside. And so if I, in this case, I just want to call into some simple code that's in the standard Java library, I don't need to write a whole lot. I'm basically writing a little stub that calls in and does a string reversal. I can do that by just providing that code and then writing some SQL to bind it. And when I'm done with this, I have a function that I can use anywhere in SQL. The result of this is we're going to compile it up on your behalf. It's really the same from Snowflake's perspective, whether you do it this way or using the external tools. And you can actually combine them. So if you've created a jar file outside and you want to write some simple code to call into it, you can actually bring that jar file along and then write your simple code here and do it inline. Obviously, this is great for simple cases, but you don't have all that deep tooling. So there's are two options, and they seem to work great for different use cases. So I've shown you a few slides. I actually want to show you some code and show you how this actually works with a real system. Like I said, I was going to do some very simple sentiment analysis. And so the example I'm going to work with here is a very simple algorithm. It's got a list of what I'm calling pause words. These are positive words, things that if I looked at a sentence, I'd say, boy, those sound like positive things, positive sentiment that's being expressed. Things like, familiar and fantastic, polished. Those all sound quite nice. And then there's some negative words like abysmal and hostile, lumpy. Nobody likes lumpy, right? So these are negative words. You could, of course, augment these lists, but they're kind of baked in here. And so all I do is I create a hash set. And then when a string comes in, I break the string apart and compare it against these and just effectively sum up the polarity, right? Is every time I see a good word, I'm going to add one. Every time I see a negative word, I'm going to subtract one. So yeah, here I am working in VS Code. Now to use this with a system, I would go ahead and compile this code and I jar it up and I put it up on a stage. Now this is sort of like these cooking shows. I've already done that because that's not super exciting. And instead, what we do have here now is a file on a stage, which is our sentiment analyzer jar. It's just the code I showed you, but again, compiled and jarred up. Tiny little thing, it's only 7K, right? And then I need to bind that to a function that I can use inside of Snowflake. And so here I have to tell it that this is a sentiment method, that's the name of it. It's going to take a string, it's going to return an integer. Remember, we're taking a string and mapping it to that sort of count of negative and positive words. The language is Java, and I have to import that jar. I can import multiple jars if I wish, right? So if I have libraries, I don't have to upload them multiple times. I can, use the library. I can go get them off Maven or go to GitHub and grab some third-party code and import it, pull the jar up here and write code against it. I can have a set of them. They just effectively get mapped into your class loader. And then I give it the handler. And so the handler just points at the sentiment analyzer.score routine, which if I look at my code is just the sentiment analyzer class and then the score routine. So it's really just pointing at that function. And so once I create this function, I have to wait for warehouse to spin up. There we go. Once I have that, I can then call this function and use it to score some. Let's try just creating the table and then inserting some reviews. So these are reviews of toasters. So, I love it is maybe a title or a review, and it's the most amazing toaster I've ever used. Maybe I need to go into the toaster business. And so then I can score these, and I see it here. I love it. I'm scoring the body, right? So amazing probably is positive, and I've gotten a +1. One thing that's interesting is, here I say absolutely toasted my mind. Well, it's greatest. I guess greatest isn't in our list because it didn't show up as a positive at all. And here, it's burnt. That's terrible, right? And so this is -1. I hate it. Probably hate shows up as a negative word. And so yes, we're going ahead and we're scoring those. We're calling that Java code. One question I get asked is, where is that Java code actually running? It's running right in the warehouse that you know and love. And so there's no additional compute, no additional charge. It's just using the warehouse that you already have to run that Java code. And we're now spinning up a JVM that runs right there and integrating it very directly into the query processor. So, very, very easy to get working. Okay, so there's Java functions in a nutshell. Nice simple case, but it illustrates the basic pattern. And really, more complicated functions are just as easy to write. There's just more code of yours. The integration into Snowflake is just as simple. All right, now I want to flip gears a little bit and talk about Snowpark and the Snowpark API. So with Snowpark, the Snowpark API, this is really, as I mentioned, it's a way for you to write logic that is going to execute in Snowflake, but in a language that is maybe one that you prefer, that's easier for you to write in. And so I'll give you an example. So this is now going to be Scala code. That is the first language that we've released the API for. Java is coming, as are languages like Python. So stay tuned for those. But starting with Snowpark for Scala, right, I'm going to import the libraries. It really is just a set of libraries that you're going to import and use in your code. And now I can interact with these things called data frames. So I get a data frame for a table, and then I'm going to go ahead and filter that. Now, the right mental model for data frame is it's really just a query. But I'm building up this query using now these language integrated constructs. So .table on my session is going to go and get effectively a select star query for products. It just represents all of the data in that products table. And then the filter says, apply filter, apply a where clause to that. Now, just like queries, until you run the query, nothing actually happens. So they are fully lazy. So as I build up this data frame, I'm not actually going to do anything. But with the data frame in hand, I can do things like show the results or collect the results and get them on my client. Or I can do things like write them to another table. In that case, the data will never leave Snowflake. When I do one of these actions, what Snowpark is doing under the covers is it is interpreting the language, right? You're building up a data structure in memory that it is then turning into a standard SQL query that is passing off to Snowflake. And so you can always go and see your query history when you're using Snowpark, just in the same way that you'd see the query history using any Snowflake queries. Right, so in our case here, again, it's going and getting all the data from products and applying a filter. You're going to get a query just like what you see here on the right. Now, there's one other really cool part about Snowpark, and that's the use of UDFs. There's more cool parts of Snowpark, but another one that I want to talk about is the notion of UDFs. And so with UDFs, I can write some code, again, now just Scala code on my client. And then by using this UDF method, I can effectively lift that to a function that will run off in Snowflake. When you use that method, what it's doing is it's going and it's actually creating a function up on the server on your behalf. So it's capturing a closure, pushing any libraries that it needs up to the server. And then when I write these data frame operations, it's, again, producing that in-memory DAG, that in-memory data structure that represents the query. And when I do something like a show, it converts that into SQL again. But now it's SQL that applies the function that I have created by making this UDF call. And so like I said, we've lifted that function up into Snowflake, and now we're executing a query that uses that function with none of the data having to leave Snowflake at all, even though the logic is defined on the client. So one way to think about this is that Snowpark is a way of writing code on the client side that will execute on the server side. And really all of these data frame operations, whether they use UDFs or not, will be executed in the server. And unless you explicitly pull the data back to the client, which you can always do, but if you don't pull it back to the client, none of the data ever has to leave Snowflake at all. So you gain the advantage of all of that scaled out, robust processing that Snowflake offers by writing some fairly simple client-side code. So what I want to do now is actually repeat the demo we just did, but do it from the Snowpark perspective. And so if we come over here, I can now show you a Scala version of it. Let me walk through what all of this code does. So here, I'm creating a session. And so this is a sample configuration. This configuration that Snowpark uses just tells my code, what Snowflake instance to connect to, what user, what the password is. This is not a password, don't worry. But the actual one I'm using is pointing to a real warehouse using my real password and my real user. So that's all that these first lines do is get a session. If you're coming from something like JDBC, you should think of the session as really being that proxy for that JDBC connection. And in fact, Snowpark for Scala is using JDBC under the covers to push queries off to Snowflake, right? So there really is a JDBC connection underneath, but the Snowpark construct is this session. I then am going to go and get a reference to that product reviews table that we've already created. And so this reviews is now a data frame, right? And so with that data frame in hand, I can now do things to it. Now, one thing I could do, I'm actually not going to do here, is I could go and I could apply the UDF, the sentiment UDF that I've already deployed up to this. And in that case, we're just using a function that happens to already be on Snowflake. I can always do that. If I want to deploy Java functions or JavaScript functions or external functions, use them via Snowpark, I can absolutely do that. But another thing that I can do is actually create a function right here on my client. And so here what I've done is I've just sort of rewritten that sentiment analysis routine now in Snowflake. So here I've got a couple of these hash sets and then a slightly different bit of code to do the scoring. But this is actually live code here on my client that I'll be pushing up, and that will happen when I call this UDF routine. And then I can use that sentiment routine here against the body column and create a new data frame that has those scored values. And then I'm going to do show, and what show will do is just wrap that query in a limit clause, in this case, a limit 10, and do a pretty print. And the width, the 100 here is just the width, so we can see a bit more of the text. So let's go ahead and run that and see what it does. And so once it starts up, you'll see here in the console, you can see that it's getting going. It is then compiling up and uploading that jar. And once that is uploaded, I will warn you, my outgoing internet is terribly slow. So any code that it needs to push tends to be a little slow. It then runs that in the server, and it actually will tell you all of the queries that it's executing along the way. And so here you can see that it's actually created that function and is running now using this UDF function. Here we go, this temporary UDF that it has given you. So it's just converting that data frame operation into a SQL query that happens to use a UDF that happens to be created on the fly from my Scala code. And so now I look at this and I say, well, I don't know, maybe I could fine tune the words in my my list a little bit. If I was using Java functions, I guess I'd have to compile that up and send another version. But here I can just go ahead and say, well, greatest. Well, greatest sounds good. Like, I don't think I've scored that one as positive. So let's put greatest in my list. And, I'm a toaster company. So, burnt is really a bad word for in the toast industry. And so let's go ahead and just change our analysis routine and then go ahead and do a redeploy. And so I'll rerun my method. I will now redeploy a new version of my UDF to the server and score using that. So it's very lively, very easy to make changes because we're just doing all of that deployment, all of that code being pushed live. So there we go. There's the function again, and then we get our updated score, and you can see, yeah, burnt puck. Yeah, that's just bad. And then finally, let me just show you, like, we can of course do more with that. So I have a little table that matches the sentiment ratings to textual descriptions. I can of course make sure that ran. I can of course come and issue all sorts of relational operations on this. So, we've seen here that we can do filters. We've seen here that we can apply functions. Here I'm doing a join. We have full support for things like aggregates as well. So, it's a pretty extensive list of of relational algebra operators that you can apply, and we keep expanding that. Again, all will execute right inside of Snowflake. And here we go. So some of these are horrible reviews. Some of them are okay. I do want to just highlight one other point. As you can see here that I actually had two outputs. That's because I did two shows, right? So I showed the scored data, and then I applied this join and showed it again. This is one of the really nice things about working with data frames, is that every data frame composes, and I can always go peek inside. So if you've ever written, a giant piece of SQL, they can be very difficult to debug because if something's going wrong inside, I have to do some work often to pull that out and figure out what it's really doing. With data frames in Snowpark, I can always just go inspect that sort of subquery at any point and get a lot more granular debugging. So it's a pretty nice way to work and debug your code. I, of course, don't need to do that. I always just comment that out and not get the intermediate result. So there you go, a whirlwind tour of Snowpark. So those are all things that you can do with Snowpark and with Java functions. And in fact, you can go get your hands on this today. It's in preview on AWS, and we'll be rolling out to the rest of our clouds in the near term. So stay tuned for that. But if you're on AWS, I would really encourage you to go get these and play with them and see what you can do with them. We don't know what you're going to do with these bits of functionality, and especially extensibility functionality, until you go do it. And it's really exciting to see the cool things that our customers go and pick up and do. So we're very much looking forward to you trying these out and giving us feedback. Another thing I want to mention is when we public preview back in June, we announced this. We had about 50 of our partners who had already hopped on this and are starting to build out some really cool things using both Java functions and Snowpark as part of the Snowpark Accelerated program. And these include things like ML scoring, ETL, a bunch of privacy protection routines, a pretty wide variety of companies and scenarios that our partners are building with us. And that's just really exciting. And it gives you a sense of the kinds of things that are possible with these features. And so, yeah, we're thrilled to have all of these folks on board. Now I'd like to talk about some of the cool things that are coming. And so I'm going to use a little bit of a metaphor here, which I think sums things up pretty well. And so, I looked this a bit like building a transit system. And I know that sounds a bit weird, but, I'm up here in Seattle, and we've been building out a transit system slowly over the last 10 years. probably more than that. I remember the first thing we got was light rail that went from downtown to the airport. And that was really neat if you lived downtown or along the way to the airport. But for me, it didn't work all that well. But the thing about transit is that first line takes a while because it's got to be long. It's got to get from place A to place B. But once you have it, you can now start to sort of incrementally add to it. And so we're going to get our line up here next month. And I'm super excited because now I'll be able to go downtown or to the airport. We're going across the lake. We'll be able to get to work. And so each of these additions are much faster. They're much more incremental, but they open up big new opportunities for the transit system to get from place to place. But in the case of extensibility, they open up abilities for you to tackle more and more scenarios. So, in my analogy, scalar functions in Snowpark were the first examples of this. We've now got inline definitions, which greatly makes it a lot easier to come in and just write some lightweight code that does things. But we have more that are coming, and so we're going to talk about a bunch of things like file access, stored procs, logging, and table functions, which are sort of the next group of features that will be coming, and they'll be coming online over the next few months in preview and then rolling out further. So I'm going to skip over just sort of recapping what all of these are. Instead, quickly take a look at each of these. I'll do demos of a few of them and just talk about some of them as well. So the first one I want to talk about is table functions. So what we have today are scalar functions, right? What scalar functions do is they really act on each row of a table when you're running a query. They really run on each row in isolation. And you can return one result. Those can be complex. You can return things like variants out of those. That's fine. We start with those for a few reasons. One reason is that they are super common. So if we look at user scenarios, probably 70 or 80% of what people really want to do, maybe more, end up being things like scalar functions. So things like ML scoring fit in that. Things like the PII routines that we've talked about fit in that. Our sentiment analysis fits in this space. And so they're really common. They're also the most straightforward for us to implement. So it's a great thing for us to build so that we can get the framework in place. And they're also very easy for users to write. The contract that you have to conform to is a very simple one. And so it's clearly the right place to start, but it doesn't cover everything. And so the next step, it will be table functions. And so you should think of these as functions that really act on a table and can return a table as well. So they could act on a row and return a table. I'm going to show you an example of that. They could also act on maybe a whole table or a partition of a table and produce 0 or more results from that. And so it really gives you a lot more flexibility in manipulating your data. They allow you to maintain state across rows. So with a scalar function, you really need to work in isolation. I'm going to score this row. I'm going to score the next row. But if I try and maintain state across rows, you'll end up shooting yourself in the foot because the system doesn't know that you're doing that, and it will try and scale out. And so you may not see all of the data. With the table function, you can express using partitioning statements what part of the data you really want to work on. And then we will guarantee that you see all of those records. And you can actually maintain state then across those records within the partition that you care about. They give the opportunity to have more than one outputs for a row. And they are a little more complex to write. They're not terrible, but they're a little bit more complex to write. And so it's a little bit more onus on function authors to create these. And in return, you get a lot more flexibility in the kinds of things you can do with them. So let's take a look at a simple table function. And so this table function here is, again, very simple, but I'm using it to illustrate the way these work. The first thing you need are a few routines to actually get the type of the result of your table function. And so this is really a result of the fact that the way that Java does generics is through type erasure. Means that we need to know fairly explicitly what the type coming back is, and you have to tell us, right? Just putting that output row or some other type in a generic like this gets removed at compile time, so we don't get that insight. So unfortunately, in Java, you actually have to be fairly explicit and say, hey, here's the output row, and this one is going to have one value in it. It's going to be a word. And then we have to have a method that gets that output class. So we will look at this class, we will call this method to get the output type, and we'll inspect the output type. And now we can understand what the types of your results are. And then you can implement a process routine that will take in, again, in this case, a single string, and split it and return a stream of these output rows. And you can maintain state across your table in this function. So we will keep calling this function with more rows of data, and you can defer and return results later and build our actual tabular results. In this case, I'm doing something very simple. I'm taking in that string, I'm splitting it on white space or spaces, and then outputting each of those individual words. And so one string goes out in and a table comes out. And so with this in hand, again, I'll save you the deployment. We will compile this up, make a class. You could do this inline as well, but here I've just gone ahead and uploaded the jar. So you can see here's our splitter jar. And then I'm gonna create a few strings to go ahead and split. So here are some first lines of books. Maybe you can tell what I've been reading. And then we'll go ahead and create a function. And so in this case, our split function takes in a string. It returns a table of strings, the name of that string column being word. Of course, you can return a table with more columns. This one's just very simple. Again, the language is Java, and we're going to import that jar that we uploaded. And now the handler is actually the class. It's not the method in the class. It's the class itself. And so we're referring to this class here. And so we now require that this be the process method. We're going to look for this get output class routine, right? So we have some specific bindings to specific methods. And that's what I mean by the contract is a little bit more complex. But when I have this in hand, let's go ahead and create that function. I can now apply it. And so this is how in Snowflake SQL, I can write a query that gets the first lines from each, from my lines, and then splits the actual first line. And so we'll return the book and the lines from the first ones here. And so here we go. Moby Dick, call me Ishmael, famous first line. There you go. So all split out. Not terribly useful in this case, but illustrates the pattern. So there you go. Table functions, a lot of uses for that coming soon. The second thing I'm going to talk about is logging. So one question that comes up is, hey, so I've got my code, it's running in Snowflake. How do I tell what it's doing? We will return errors. So if your code does throw an exception and that gets returned, back up to Snowflake, we'll go ahead and terminate your query, and we'll show you that exception. That's pretty limited, and that's not as useful as it could be. What we're doing is we're adding in logging, and for Java code, this is done through really very standard SLF for J style logging. And so if you've got logging using SLF for J in your code, it'll probably just work with the system. You're going to go ahead and get the logger for your code and then log to it using just standard SLF for J. But we're going to tap into that, and we're actually going to route those log lines to a table. And so I don't have a demo to show you on this today, but you're going to have a table for your account. We're going to populate that with a whole bunch of fields that tell you, what exact object threw the error or wrote the log line rather, what user wrote the log line, what database it was in, all of that. You can then apply things like row access policies or create views on top of this to give specific users access to the log lines that they need right through Snowflake. And of course, I should mention that, of course, one of the columns in that log table is exactly the logging information that you've passed back. And so you can go and build queries on top of your logs. You have this nice unified logging system across your entire account. And so, yeah, again, from the Java perspective, this is really straightforward. We are going to be building integrations to the same logging infrastructure for SQL and JavaScript as well in the future. And so all of your logs for all of your code will be able to route to one place, which gives it a really easy way to, for example, get all of the logs for all of the things for a particular session, right? No matter where they were written. So that unified logging is a super powerful thing for debugging when things go wrong. So again, not there yet, but coming soon. Okay, so the next feature I'd like to talk about is, I actually think one of the more exciting ones, but it doesn't maybe sound that exciting out of the gate. So maybe let's imagine that we had some sort of data pipeline that we want to run. And the specifics of this aren't super important, but this particular pipeline, it's going to take in a session here. So it's a Snowpark data pipeline. We're going to take in the session, and then we're going to query the sales table. And if we find sales that are above a certain amount, we're going to go get a bonus and give the sales team a bonus for making that great sale. And so maybe I want to run this pipeline every day to hand out bonuses to my team. And so I've got a main routine that's actually going to go connect to Snowflake, get that session, and then call into the pipeline and do this. But a question that I get from customers fairly frequently is, well, all right, so I've got this Snowpark code. Where do I run it? Do I still need Airflow to schedule this? And the answer is, well, yeah. I mean, where do you run this today? It lives somewhere, right? We actually don't care too much where it lives. The answer is really very much the same as if you were to write, JDBC code in Java and Scala. You can go host that somewhere. You could put that in a Lambda function. You could run it on a VM. You could do what I've been doing with Snowpark code here today and actually running it here on my laptop. But that's not really very satisfying. It's not sort of an encapsulated piece of logic. What you'd like to be able to do is actually bring that right into Snowflake and run it in Snowflake itself. And that's what stored procedures let you do. You bring it in, you create a stored procedure, and now you can do things like have it scheduled with tasks. And so now if I want to run that thing every night, I can go do it. The way this will look is I will go ahead and create a stored procedure. Now you'll notice that this bonus pipeline takes in a session. Here, I've got an apply bonuses routine that actually takes no parameters at all, but returns a string. It's pointing at this bonus code that I've uploaded, but it's pointing at the bonus pipeline. So I'm actually skipping this main routine that's creating this session. And so there's a little something funny going on here, right? In my actual pipeline, I created a session and then ran this routine. Here, I'm binding directly to the routine, but I'm not creating a session. And what's happening is when I run this procedure, Snowflake is actually going to go and insert a first parameter. You can have parameters to your procedure, but we're going to insert that first parameter as a session that Snowflake itself has created for you. And that'll effectively be a loopback session. So whatever session you call the procedure on, the pipeline will then get that and run. And so again, this is really the way to now take your pipelines that you've written in Snowpark and bring them and put them right inside Snowflake. Incidentally, we will also be making it very easy. As I mentioned earlier, this session makes use of JDBC underneath, and there actually is a JDBC connection. And so if you prefer to write JDBC code, you're going to actually be able to do session and get the connection out and then write JDBC code against that as well. So that'll be coming as well. So again, we think Snowpark is probably the slickest, easiest way to write code against Snowflake. But if you want to port old JDBC code and run it in a stored procedure as well, that'll be possible too. So yep, this answers that sort of missing piece of where do I run this? And I think a pretty slick way. All right, so that's stored procedures. The last feature I want to talk to you about today is file access. And so it's already possible when you create, for example, a stored procedure like this, you can import a file and read that in your code, but that importing is not the same thing as actually acting over files. And so what if you actually want to write a function that operates over files, say in a stage? And so what you're going to be able to do in the future is write some Java code that actually takes an input stream, right? So that's really just a series of bytes that you can now act on. In this case, I've got maybe some ML code that detects whether there's puppies in an image versus kittens. I won't get into a holy war about what's cuter, but I do like puppies. So once I have that, I'll be able to create a function that passes in the path to that file, right? So that could be in a stage, right? So this is a stage path. And what Snowflake is going to do is when I pass in that path, it's going to see that you're mapping a string here to an input stream, and it will actually go get the contents of this file and provide it to your input stream data. Now, a few interesting things here. First off, we also have this file table work that's coming. And these things work really well together because now I can write queries that don't just have a static thing in it, but actually get a listing of a stage and then pass each of those files off to some Java code to do processing of those files. That'll be a very nicely integrated solution. The other thing that is really neat is that if you put file access together with table functions, it actually gives you a way to do custom parsing. So if you have some novel file type, it's not one of the ones that Snowflake already supports, like Parquet or a CSV file. You can go ahead and write your own Java code that takes in that file type and produces rows of data using a table function. So these things will work together, and it'll give you a way to do completely custom parsing of files right inside Snowflake. All right, so we've seen today a few things. I've talked to you about some of the things that are actually already out in public preview. Go get your hands on them. Please play with them. Please let us know how they work for you. Good, bad, or ugly. We love the feedback, but we really love to see some of the neat things that you're doing with it. We saw about Java functions. We saw how Snowpark works and how those work together to do some really cool things by pushing code from the client to the server. And then we've taken a look at 4 features that are coming in the near future, right? So we talked about logging, and we talked about table functions. We talked about stored procedures, and we talked about file access. And so these are things that are going to build on that functionality that we've already got in and open up a bunch of new scenarios for you to develop. Bring your code, bring your interesting logic, and do cool things. So yes, happy hacking. And thank you for joining me today for this session.